will go well for you. So discrete and continuous random variables. What is the sample space for tossing a fair coin 3 times? So if I flip a coin 3 times, what are all the possible outcomes? I could get heads, heads, heads. Okay. I could get every combination of 1 tails and 2 heads. So you have to write that out. It could be tails, heads, heads, or it could be heads, tails, heads, or it could be heads, heads, tails. Okay, we could also get 2 tails, right, and 1 head. So I need every combination of 2 tails and 1 head. So it could be heads, tails, tails, or tails, heads, tails, or it could be tails, tails, heads. And the last choice here is we could get all tails. Okay, so there's 8 different ways that you could flip a coin and get heads or tails, right? So then it says define variable x as the number of heads obtained. So we are going to do random variables, and we'll write down a definition for what a random variable is here in a minute, but it's any kind of chance process that has a numerical outcome, all right? So we're counting the number of heads. So x represents the number of heads in 3 flips of a coin. So how many heads did I get here? I got 3 heads. How many heads did I get here? 2. How many heads did I get here? 2, 2, 1, 1, 1, none. Okay? And we're going to make a probability distribution for the number of heads and then the probability of that occurring. So if I flip a coin 3 times, what is the probability of getting all 3 heads? 1 out of 8. Okay, what's the probability of getting 2 heads? 3 out of 8. And 1 heads? 3 out of 8. And no heads? 1 out of 8. Happens 1 time out of 8 times. All right, so we would make what's called a probability distribution for this random variable x, and we either get 0 heads, 1 heads, or 3 heads. And the chance of 0 heads was 1 out of 8, and the chance of 1 heads was 3 out of 8, and the chance of 2 heads was 3 out of 8, and the chance of all 3 heads, 1 out of 8. So, in case you forgot, a probability distribution always lists. I was supposed to take attendance before we left. Oh, I'm recording this. Okay, and this is the graph of the probability distribution. So remember, you can get 0 heads, 1 heads, 2 heads, or 3 heads, and then it just goes up to their probabilities. Don't forget to label, and instead of putting value, put what this actually means, number of heads in 3 coin tosses and probability. And then they're going to ask you to do SOX, describe the distribution. So do you guys remember what SOX stands for? What's S? Shape. This one's roughly symmetric. What's O? Yeah, there's no outliers. What's the C? Center. And what's the S? Spread. All right, so we'll look at some SOX too. What's the probability that we get at least 1 heads? Okay, at least 1 heads out of 3. So we're going to go back, look right here. At least 1 would be 1 or more. All right, 1 or more. And what's the probability of getting 1 or more? 7/8. All right, so 7/8. You could also do, that would be 1 minus probability of none. Okay, 1 minus 1/8, which is 7/8. All right, I would write down just this first sentence. We already wrote down what a probability distribution is, okay, but we'll review that. So the first part there, a random variable. This whole chapter is going to be about random variables. Takes numerical values that describe the outcomes of some chance process. This could be number of cracked eggs in a carton of eggs. Okay. This could be number of students who get an A in AP statistics. Not true. All right. And then we have the probability distribution. Again, we talked about this. You get the possible outcomes and their probabilities, so both are provided. All right, we do want to talk about today discrete and continuous. A discrete random variable x takes a fixed set of possible values with gaps in between. I would write down just this first sentence, okay? A discrete random variable takes a fixed set of possible values with gaps between. In other words, for the number of heads in 3 coin tosses, can you get 2.5 heads? You cannot. Can you get 2.1 heads? You cannot. All right, you either get 0, 1, 2, or 3. That means there's a gap in between, all right? It's like a fixed number, and you can't have some in-between value like a fraction or a decimal, all right? So probability distribution, we just talked about what that is. You get the outcomes, you get the probabilities. Just a reminder, all your probabilities have to be between 0 and 1, and for it to be legitimate, the sum of the probabilities right here has to equal 1, just like we did in the last chapter. Okay, now a continuous random variable would be something that could have a decimal answer. For example, your height is continuous, and you know when we do norm CDF, anything norm CDF is continuous, which was all those height questions, right? So I could be 5, 2, and a tiny bit more, okay? So something like that. All right, let's practice discrete or continuous. Do you think the amount of time it takes to run 110-meter hurdles is discrete or continuous? It is continuous because that decimal, you could like stop your stopwatch and it's going to be like 12.25678 seconds, right? And you don't round to like 12 seconds because all the swimmers, they're like all within 1 second of each other, right? And it like ends and it's a continuing decimal and you beat them by like a hair of a second, okay? And then how about the number of hurdles cleanly jumped? That would be discrete, okay? You cannot jump 1.5 hurdles. Okay, a student's age, this one's tricky. Continuous, because I'm just like 1 second older right now than I was a second ago. All right. But number of birthdays is discrete. All right. You are a certain number of birthdays years old. All right. Your shoe size. This one's discrete. You have to fit into one of those half sizes, right? They provide you with a 7.5. Even though it's a half, you can't have like a 7 3/4 size, all right, or a 7.25678 size. So you have to fit into a half size. But your foot length is continuous because it could just be like a teensy bit bigger than someone else's foot length. And your height is continuous. All right. So babies, when they're born, they get an APGAR score. All right, so we're going to define our random variable x as an APGAR score. This means you're like awesome and really healthy, and this one is not good. Okay, so between 0 and 10. And this is the probability, so we have a lot of babies in like the 8, 9 area, okay? Show that the distribution for x is legitimate. What are you going to do to check if it's legitimate? Make sure that these equal 1. And also you can't have any negative probabilities. Make a histogram. All right, so it's been a while since we've made a histogram, but you are going to make a few in the homework tonight. What would you put on the x-axis for this? Yeah, but say what it is. It is a value. I would say APGAR score, all right? And then what goes on the y-axis? Probability. You're probably going to only need to go up to like 0.5 because that highest one is 0.437. All right, and then draw all your little bars. And there's no space in between, okay? You do put space in between categorical data, but all of this is numerical. It's a histogram. You put them right side by side. When it says describe what you see, what are you going to do? Yeah, yay. Okay, doctors decided that APGAR scores of 7 or higher indicate a healthy baby. What's the probability that a randomly selected baby is healthy? So if you get a 7 or higher, and I want you to practice writing this probability statement out, okay? Random variable x is the APGAR score, and so you get a 7 or higher, that would be x is greater than or equal to 7. And all we would do is add up these 4 probabilities. Greater than 7 means you get a 7, 8, 9, or 10. Add those 4 up and you got an answer. It's like 90%, so that's good. All right. Now, let's say you did your histogram, which should look like this. Let's just review socks real quick. Okay, what is the shape of this graph? Yes, pretty strongly skewed left. Be sure you say the shape of the distribution of APGAR scores is skewed left. You have to have context in there somewhere on the AP exam. Are there any outliers? No, there has to be like a space probably. They're all connected, so it's good. All right, now center, this is a good one to talk about. All right, to find the center, I would do median on these, and I would actually find the 50th percentile by adding the percents across right here. So I would add here to here, and you're like, that's still not 50th percentile. And I would add the next one, still not 50th. Add the next one, 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 add the next one. I still think we're not in the 50th, but I don't really remember. Let's pretend like we're not, and then you add the next one, you're definitely going to be in the 50th by that point, okay? Make sense? Once you cross over the 50th percentile threshold, that's the bar that contains the median. All right, so we would say 9 or 8. I don't remember which one it was. I think it might be 8. I don't know. All right, and then for spread, I would just say that the scores range from 0 to 10. Just do your range, okay? All right, let's try another one. So these are some North Carolina states. Their grade distributions for statistics. And instead of doing an A, B, C, D, or F, they made it like a GPA, right? So they made it a 4, 3, 2, 1, 0. That way it could be numerical, and you could take on a numerical value for your grade. All right, and then they've got the distribution, the percentages for each. So they're going to ask us some questions. Say in words what this means. The probability that random variable X, which is the grade in the class, is greater than or equal to 3. Raise your hand if you can tell me what that means. Yes. Yeah, the proportion of people that got a B or better, right? So we'd add these two together and get that lovely answer. Okay, write the event the student got a grade worse than C in terms of random variable X. Someone different. How would I do the P statement for worse than C? What do you think, Alex? Yeah, less than 2. Okay, there is another way to write this. You could also do less than or equal to 1, right? Less than C means you got a D or an F, so less than 2 or less than or equal to 1. And then they would want you to actually calculate that. So there are 12% of people who got a D or an F in this class. All right, sketch a graph and describe what you see. All right, so you would sketch your lovely graph right there. And you would do socks, okay? What would the shape of this distribution be? Skewed left, no outliers. Okay, for the center, let's see if we can actually figure this one out. What do you guys think the center is? Where's that median? I agree, it's 3. If you add these, you're at 12. Now you're at 32. Now you're going to cross that 50th percentile. All right, so the median is a B, okay, or a 3. All right, and then we would do the range from 0 to 4 or from an F to an A. Grab this worksheet. Just kidding, I still have to pass it out. Don't do this part here, okay? Start here once I pass it out. But go ahead and write this down, and then I'll pass out your packet.